alternator. Drillings machines internal and external thread. Drillings is a process of making holes on workpieces by using a drill. Part of drills pictures 1 given that this is the drilling. This is the part of tank, and this is the shank, and this is the part of body. This is the part of body, and this is the part of flute. This is the part of flute, and this is the part of land. This is the part of point angle. This is the part of point angle, and this is the part of cutting tip. This is the part of cutting tip, and this is the part of chisel edge. This is the part of chisel edge. यानी कि पार्ट्स 1 टैंग, शैंक, बॉडी, फ्लूट, लैंड and point angle, cutting leaf, chisel edge, and tang. Tang is the part that fit into the slot of drilling machine spindle. Shank, this is the driving end of the drill which is fitted on the machine. Shanks of two types: taper shank for large diameter drills, straight shank for small diameter drills. The shank may be parallel या trapped. Picture 2 and 3. Drills with parallel या straight shank are made in small size of to 12 mm 1/2 in diameter, and shank has the same diameter as the flutes. Tapered shank drill are made in size from 3 mm यानी 1/8 inch diameter up to 50 mm यानी 2 inch diameter. This is the straight shank. This is the straight shank and straight shank drill, and this is the part 3 is tapered shank. Tapered shank and tapered shank drills. Body. The body is the portion between the point and shank. Flutes are the spiral groups which run to length of the drill. The flutes help to from the cutting edge to curl the chip and hollow them to come out. The coolant to flow to the cutting edge. And pictures 4 is given that this is a drillings and drilling bit. Land margin. Land margin is the narrow strip which extends to entire length of flutes. Diameter of the drill is measured across the land margin. Body clearance. Body clearance is the part of the body which reduces in diameter to cut down the friction between the drill and the hole being drilled. Wave. Wave is the metal column which separates the flute. It gradually increases in the thickness toward the shank. Drill bit holder. Drill chuck. The drill chuck is attached to the main spindle for stand shank basis. Given a pictures 5. This is the drill chuck. This is the drill chuck, and sleeves. Sleeves is used to match bit tapers and the spindle taper holes. Given picture 6. Socket. This is used when the main spindle length is too short and the bit is changed frequently. Picture 7. The tapered shank drill are held in taper socket in the machine. Pictures 8. Given a picture 6, 7 and pictures 8. This is the sleeve, this is the socket, and this is taper shank drill. Parts of drill holders. The tang on tapered shank drill enable easy removal of the drill from the socket at the end of the drilling works. This is done use a draft. The tang also serves to prevent the drill from rotating in the socket. Pictures 9. This is the drift and tang. This is the tang of tapered shank, and use of coolant. A coolant is used to cool the cutting tool and the job. Drilling machines making holes in sheet metal by using a solid puncher is a slow and inefficient process. It is necessary to drill holes when working with heavy material. The holes can be drilled by hand, yeah, by machines. When drilling by hand, a hand drilling machine, pictures one on the electric hand drilling machine, is used. Twist a drill are used a cutting tools for drilling holes. The hand drill is used for drilling holes up to 6.5 mm diameter. The the portal portable electric hand drilling machine is um, very popular and use a power tool. It comes in different size and capacity. The handle shown pictures 2 is called a piston grip. Pictures 1 is given that this is a fixed handle and this is the small handle and this is the chuck, sail and jaw handle machines. The parts of an electric hand machines are shown in pictures too. This is a geared key, chuck and trigger switch, a handle, and this is electric cord. This is a chuck key, and this is the electric hand drill machines. A precaution to be observed: make sure the holes are properly located and punched with a center punch. Check the drill size. If the marking on the drill are not clear, use a drill gauge. Be sure the drill is properly entire. Enter the chuck by tuning, rotating, and be sure the work is mounted properly in a holding device such as vice of G-clamp. Check the centering of the drill after the point has just started in the metal. Located the hole with a center punch. If necessary, feed the drill with a light even pressure. Type of electric drilling machine: some of the electric drilling machine are listed here: the sensitive bench drilling machine, the pillar drilling machine, and the radial and drilling machine. Radial drilling machines, as you are not likely to use the column and radial type of drilling machine now, only the sensitive and pillar type machine are explained here. This is the fixed handle and this is the depth gauge and belt guard, driving motor, chuck, spindle axis, and this is the columns, pillars, table cock, work table, base, and this is the bench drilling machines. Sensitive bench drilling machines. The simplest types of sensitive bench drilling machines is shown in the figure with its various part mark. The machine is used for light duty work. The machine is capable of drilling holes up to 12.5 mm diameter. The drills are fitted in the chuck or directly into the tapered hole on the machines of the machine's spindle. Different spindles speeds are achieved by changing the belt position in the stepped pulley, and this is the speed changing driver and speed pulley for drive on high speed and normal speed, constant speed, and this is the very low speed, and this is the drill bit motor. Belt arrangement in belt drilling machines: for normal drilling, the work surface is kept horizontal. If the holes are to be drilled at angle, the table can be tilted. The pillar drilling machine: this is an enlarged version of the sensitive bench drilling machine. These drilling machines are mounted on the floor, are driven by more powerful electric motor. They are used for heavy duty work. Pillar drilling machines are available in different this is the wood this is a wood piece as a sport, and as work piece sport with a wooden piece. This is the vice jaw and work and screw, parallel blocks, bolt, and this is the parts of machine size. Large machines are provided with a rack and pinions machine mechanism for moving the table for seating the work. The machines divide. Most of drilling works can be held in vice. Ensure that the drilling does not drill through the vice after it has passed through the work. For this purpose, the work can be lifted up and secured on parallel blocks, providing a gap between the work and the bottom of the vice. Picture 6, given that work pieces which are not accurate may be supported by wooden piece. Given a picture 5, parallels. The workpiece can be sent on parallel to raise it of the reference surface and still maintain parallelism. Parallels are made in pairs precisely the same dimension from hardened steel finish guard with the opposite face parallel and adjacent face square. A variety of size available. Cutting speed and RPM revolution per minute. Cutting speed, the cutting speed and RPM for a drill to give a satisfactory performance, it must operate at the correct cutting speed and feed. Cutting speed is the speed at which the cutting edge passes over material while cutting and expressed in meters per minute. Cutting speed is also sometimes stated as surface speed peripheral speed. The selection of the correct cutting speed for drilling depends on the material to be drilled and the tool material. The recommended cutting speed for different material are given in the table. Based on the cutting speed recommended, the RPM at which a drill has to be driven is determined. Material being a drill, cutting speed मीटर पर मिनट, एल्युमिनियम 70 से 100, ब्रास 35 से 50, ब्रोंज 20 से 35, कास्ट आयरन ग्रे 25 से 40, कॉपर 35 से 45, स्टील माइल्ड 30 40, स्टील मीडियम कार्बन 20 से 30, स्टील एलॉय हाई टेंशन 5 से 8 और थर्मो सेटिंग प्लास्टिक लो स्पीड ड्यू टू एब्रेसिव प्रॉपर्टीज 20 से 30. The RPM will differ according to diameter of the drill. The cutting speed being the same, larger diameter drills will have lesser RPM and smaller diameter drill will have a higher RPM. Calculating RPM, CS is N pi D 100,000 into CS by pi D. N is equal to RPM, CS cutting speed मीटर पर मिनट, डी डायमीटर ऑफ ड्रिल इन पाई बराबर 3.14. एग्जाम्पल, कैलकुलेटिंग द स्पिंडल स्पीड RPM फॉर हाई स्पीड स्टील ड्रिल ऑफ 24 डायर टू ए कट माइल्ड स्टील. द स्पीड 1000 into 30, 3.14 into 24, 398 RPM. This spindle speed is 400 RPM. The feed of drill, the penetration of drill in job per revolution of drill. Point angles and material. The correct point cutting angle B of the chisel depends on the material to be chipped. Sharp angle are given for soft material and wide angle for hard material.